Hi, welcome to the Kiwi Ads and Mods tutorial on heel lifts and arch fills. To start off with, heel lifts can be ordered separately or attached to the orthotic in four different lengths. We have heel, three-quarter, sulcus, and full or to toes. And just to give you an idea, here's a sulcus length lift with the demarcations there and just a single heel lift. Really easy to get these cut and ground to specific within a millimeter, just to add in as a separate piece if you want to trial a certain lift height with a patient, if you're not sure whether the shoe will accommodate it, or if you're trying to suss out the best lift height for a leg length discrepancy. So separate ones, really simple. For attached lifts, it can become a little bit more complicated. For any of the hard shells, polypropylene and graphite, typically what it means is that we do need to add on the EVA extrinsic stabilizer to provide a platform for us to actually attach a lift. Now, that may mean that on the opposite side, if it doesn't come with an extrinsic EVA stabilizer, there might be a bit of a different feel between the two shells. So if you're adding a lift to one side, you may want to consider having that EVA stabilizer on both so that you're reducing how much asymmetry is within the actual device. As you can see here, this one is just attached on the heel. You do also have the option of adding the lift three-quarter length, sulcus, and full attached onto the shell, but it may look a little different depending on what type of shell it is. In order for us to actually add the material, there needs to be a stable configuration. If we add this onto a sulcus length lift, essentially what it means is that we'll typically be adding an extrinsic EVA forefoot stabilizer. And again, either to sulcus, where you want the lift to taper off, or to a full length, like in my demonstration model here. So this one we have some attached to the heel, and then a continuation of that EVA all the way full. Whereas on the opposite side, to compensate for a leg length discrepancy, it would not have that forefoot stabilizer. Right? So that's what it would typically look like, either heel, sulcus, or full length attached. Three-quarter length would be a special case, and essentially what we would need to do to have the lift taper off just at the end of the shell is actually add an arch fill. And we'll get into what that looks like in a minute, but essentially means that we would need something to fill in the base of the orthotic here so that there's no awkward gap in the middle. You don't want any holes going through the orthotic. It needs to be one solid device. So hopefully that makes sense. If you want to see an orthotic with an arch fill attached, you can see this is one that has an extrinsic EVA stabilizer on the heel, and then an additional PPT arch fill. And then for something like this, we could, if we wanted, add an attached lift, and then taper that either to the three-quarter line, sulcus full length, and on and on. So that's lifts in a nutshell. One note for modifying lifts: if you do need to measure a lift, if you suspect the accuracy may be off of the device, or if you're trying to adjust the shape of the height of the lift for somebody, the best way to do it is by taking a flat surface and a good ruler that ends right at the zero, and put that perpendicular to your flat surface and measure at the center of the calcaneus. The reason is that if you measure just based off of the shell, well, all of these areas have been beveled. And if you apply the ruler directly to the orthotic, whether it's here or at the back, you're likely going to come up a millimeter long or short, because of the way that it's been tapered and beveled. Geometry. So that's lifts. For arch fills, Really, the main purpose of an arch fill is to add integrity to a device or rigidity. Now, if you use a material for the shell that's a polypropylene, you often don't need an arch fill because you can dial the millimeter thickness of that shell to the exact rigidity that you want. And sometimes, if it comes out a little bit more flexible than you anticipated, you may want to send it back to have an arch fill added. That's perfectly fine. But once you get a sense of how the flex of a shell is for a certain patient, you shouldn't have to really add too many of these. However, where we see it a lot more frequently is on our soft shell devices. So anything from our EVAs, our vacuum molded EVAs, to our rigid plastizotes. Essentially, if you choose for EVA, if you switch over on the template from direct EVA, which is the default, to a pressed EVA, which on the order form will just say EVA and then the durometer or hardness number. So for our sensitive, the default is an EVA 35, but it's direct milled, so you can flip it to EVA 35. And the difference is that when we vacuum mold it, we vacuum mold this material in sheets of about 9 or 12 millimeters, depending on the size of the foot. And so, if you just have a single layer of that shell, it can be quite flimsy on its own. Now, if you're just looking for a soft, accommodative device and you don't want the extra bulk of that arch fill, that's as much as you might need, right? Then the shoe may be doing a bit more work to create structure. That's certainly the idea behind our running template, typically without an arch fill to save on weight and bulk, but also a slim fit shoe just isn't going to accommodate that. And the shoe is actually going to be acting as an arch fill to hug in against the shape of the orthotic. So those designs sometimes don't require that extra material. On a square, more straight lasted, deeper fitting shoe, this is when we'll often add in an arch fill. If you're going to switching to that pressed designed EVA, or if you want to have multiple densities in your orthotic, if you want the shell to be a slightly firmer shell like EVA 55, which is the firmer durometer, firmer hardness, uh, but you want there to be a little bit of forgiveness underneath the arch, you can switch it to pressed first of all, and then in the arch fill section, select a PPT or an EVA 35, and having that be slightly softer in that second layer underneath the MLA and the LLA, it means that when the foot goes to push and pronate down on that device, there's going to be a little bit more give than there would be if it was just an EVA 55 all the way through, like in our direct mill models. So there's your option for a soft shell with no arch fill, much slimmer fit, less weight, but a little less integrity. It's a little bit more flexible versus pressed EVA or rigid plastizote with an arch fill. A little bit more integrity, a little bit more gravitas to that shell, and requires a little bit more volume in the shoe. All right. As an example, in the real world, for what this might look like in my own orthotic, you can see I use a polypropylene shell, but at a fairly flexible springy durometer. This is actually my running orthotic that I use. I like polypropylene for a little bit more integrity, but as you can see, I've put an arch fill on the bottom of the orthotic, and because there's no extrinsic EVA hindfoot stabilizer on that device, that arch fill actually covers right around and wraps the heel to create a nice flat base that's nice and stable and secure in the shoe. But when I go to pronate on it, and I'm quite a heavy over pronator, there's a lot of spring and movement still to the device, but it has a lot of control and support for where I need it. So that gives you some idea of arch fill on arch fill on hard shells. This is what it would look like if there already is an extrinsic stabilizer. This is what it looks like if there wasn't one. And then, of course, the designs that have a softer shell that either do not have any arch fills or do. And just a note again, for the direct mill EVAs, which are sensitive and are unloader come default, you do not need to add an arch fill to those because they are, in a sense, already arch filled with the same durometer. The way that that process is done is we just use one block of foam and mill the shape right out of that. And so it simplifies the process quite a bit on our end. If you have any questions about heel lifts or arch fills, please let us know. Always feel free to reach out and chat through email, tech@koslab.ca. Thank you.